Hey everybody, this is Will with SRT Amplification. I know I haven't put out a video in quite a long time, probably almost a year ago. I put out my last video. I've been very busy with my day job, and I've still continued to do repairs on amplifiers and modifications on amplifiers, mostly guitar amps, for clients all over the area here. But I've recently got into restoring, or at least electrically restoring, old radios. I don't do any of the wood or anything like that. There's a guy here that does the wood stuff, and I just do the electronics, the innards of it. And he's coming up with all these radios, and he's actually getting up quite a few of them. He's going to give to his grandkids, so he's wanting them all fixed up. I think he wants like 15 or 16 total of them, and I've done quite a few of them so far. And he's primarily getting the wooden cabinet radios, and from around the late 30s, early 40s, all AM radios. And I've been restoring them for him. And since I've had a lot of experience doing tube amplifiers for guitar amps and PA amps and stuff like that, as well as all the other solid state stuff I do. But in the tube realm, um, he he brought me this first radio, and ever since then we just been going through them and getting them working and uh, maintained. If any tubes need replaced, clean the sockets, the potentiometers, put new power cord, polarized power cords on them, recap them. I've been recapping all of them. Uh, After all, they are 80 years old. And then doing a basic AM alignment on them, which are really easy on these. There's not much to it, and perhaps I'll do a video on that uh, at some point. But today I wanted to uh, go over some things that I've learned about working on old radios that you think you know a lot, and sometimes you think you know everything, but then you run into some situations where, they don't do it that way anymore, or they did it differently, and then you have to relearn things. So, and this is a case of that. There were some nuances that I've had to work through when I started working on, 1960s and 1950s things. And I pretty much had all of that figured out. And now that I'm into the 30s and 40s, it's a whole new ball game. So I just wanted to share some tips with you, and I hope some of these things help. And if so, leave some positive comments there. Anything that you've learned that I didn't that I don't cover on this video, please put them down below. I'm always learning, and you can probably help somebody else that's also doing this. So let's talk about this a minute. Currently, I'm working on a Belmont radio from, I believe it's from 1938, 1939, somewhere in there. The date codes are in the 38, 39. It's probably a 39. Was when it was manufactured. Maybe as late as 40, but somewhere in that area. Um, it's a model 585D. Okay, and that's very important because as I found out, they actually made an A, a B, an Alpha Bravo with Charlie, and a Delta model of these. They may have made even more, but after I found the one that I was looking for, I just kind of stopped looking. So where did I find the schematic at? Well, there's really two sources that I use, and I'll put links down in this description below on where to find these. But let me pull this up for you real quick. Here is the Beitman has 30s and 40s all the way up to the 60s. I've got them pretty much all right here in PDFs. So that's a good resource. And then the riders, and they don't put theirs into years, but more into volumes. But it really was kind of a chronological as far as years go. And one thing I found was Originally, I had found the model 585 in the Riders Volume 6. Uh, and I started using it. It was close enough for what I needed. Let me zoom out here so you can see this. It was close enough for what I needed, but this particular one only covered the Alpha, Bravo, and Charlie models. As you can see here, it says Alpha, Bravo, Charlie. Well, at the time, I didn't know which one I had. Okay, it just said 585 on it. And mine ended up matching more with the Charlie. The Bravo and the Charlie are both the same schematic right here, and the Alpha is right up here. So I was kind of going off of this one, but then I noticed some of the tubes didn't match up, particularly this one, the Alpha tube, and this IF tube or RF. This is an RF amplifier tube. Um, they weren't matching up. So I knew something was off. Some of these values in the capacitors and stuff were off. So I went to the Writers Volume 7 to see if they had a 585, and they did, and they had the Delta model here, and that was the one that matched perfectly with the one with the radio I'm working on. So that's great. So this is what I started using. Okay, so Riders, Beitman, look them up. Like I said, I'll put the links down below. You can find, they don't have every model. I've actually came across some models that I cannot find a schematic for. They're either so obscure that they didn't make schematics for them. Sometimes you can, through a little bit of research, you can find out that this model was actually made by somebody else under a different model name. And if you go to that, these in these manuals here, these schematic manuals, either the Ryder or the Beitmans, the radios are listed alphabetically by brand. So like before Belmont, I believe the next brand up is like Atwater Kent or something like that. I don't remember exactly, but I could probably scroll up and find it here. But um, it's okay. Where are we at here? Sorry. Um, but yeah, so they're listed alphabetically by manufacturer. Okay, so anyway, some of the tips that I want to give you out there, that if you're into restoring these radios, or you have one and you just want to repair it, or make it where it actually plays, I may end up doing a whole series on this as I go through and learn things. I may do some radio repair videos as well. But for now, it's just going to be kind of a general. Hey, if you have done electronic repair on newer equipment, or even stuff in the 50s and 60s, and you end up getting something from the 30s and 40s, these are some things that you may not know about. Okay, those kind of things. So we'll start right here with the schematics and the way they did schematics back then. I think it's actually great, but and if you were a repair person or a hobbyist or a technician or whatever, doing something with one of these radios back in the day, you probably knew all of these things, okay, because that's just the way it was. But when you've come up learning through modern schematics, modern electrical components, electronic components, and modern terminologies, even some in some cases, and you go back and try to figure out what they're talking about here, it's a learning curve. Okay, so forgive me, I'm only 50 years old, or I will be in a few months 50 years old. But you know, like I said, if you got somebody in your area that works on radios and they're in their 80s or 90s, even, um, they're all starting to, unfortunately, they're all starting to die out, right? The old dinosaurs. But if you do have somebody like that, they probably know this stuff inside and out, and it's not foreign to them. But for somebody who learned on a more modern uh, time, then yeah, it's a learning curve. The first thing I had to learn was, um, we'll start right here with the resistors. Number one, I looked at this resistor chart when I was making up, because I go through and test each resistor and make sure that they're good. Uh, for one thing, the type of resistors that are in here, they're called bed resistors. Okay. Um, and the reason they're called bed resistors is because you read the color code on them not by rings or by stripes around the resistor body, but by the color of the body is the first, would be like the first color ring, right? Stripe and band, I guess would be the appropriate terminology. And then the end of the resistor is painted a color, right? And that is the second band color in a modern resistor, if you think about it that way. And then there's a dot on the body that is of a certain color, and that is the multiplier. Okay, so BED, body color, end color, dot color. Okay, and then there's also colors on the other side of the, or there could be colors on the other end, either gold or silver, and that would be your tolerance. But if it's just painted the uh, the same as the body, then it's a 20% tolerance, which all of these in here is what they are. Well, there are some, I guess there are some 10 percenters. But anyway, these are carbon resistors for the most part. There are some wire wound resistors in there, one. But one thing that's going to get you on this, and this is what got me, is I'm testing these resistors. And I'm used to, an M being mega ohms, right? And I'm thinking to myself, how in the world, I mean, if you look down here, there's an 800 mega ohm. I was like, how in the world do they have an 800 mega ohm resistor in here? I mean, it just doesn't, it didn't even make, I mean, in all my years of working on, amplifiers stuff, I never ran across an 800 mega ohm resistor, right? And so the more I started testing these things, I'm thinking, man, they're off by like a factor of a thousand, like three zeros are off here. And so anyway, it got me thinking, okay, I saw this right here. It says 1 meg. I was like, okay, now that probably is 1 meg. And sure enough, it was 1 meg. So then I was like, okay, all right, this M is like the Roman numeral for 1,000. Okay, instead of using a K, they're using an M. And so then I did some research, and sure enough, that's what they used back then. Don't ask me why. And some of you out there are like, oh, yeah, you didn't know that. Oh, you guys probably weren't born in this time either, or raised in this time either. So, yeah, the M is not meg. It is the Roman numeral 1,000. Okay. So it's basically for every time you see an M on a schematic like this, just replace it with a K and you're good to go. Okay. So once I was over that hump, I was like, okay, I'm good to go on the resistors. And then I get down to the capacitors. And I've already done a video on this before. I did a video a while back. You can maybe I'll put it as one of my featured videos at the end of this video. But I did a whole video on capacitors, how to read the color codes, how to convert the conventions that they usually use on schematics, the whole microfarad for picofarads, the whole thing about when back in the day when the capacitor manufacturers stamped the values on there, they didn't have the font for the micro symbol, the mu symbol, and so they just used MFD because they thought, well, people aren't going to think this is a megafarad, right? A 40 megafarad capacitor, right? So they used MFD a lot. And so I've already done a whole complete series on capacitors. But here, this was really weird. Like, this is a misprint on this particular print. It says 0.8 microfarads. This 8 and this 8 right here, so C13 and C18 are the can caps, the main filter caps. And they're really 8 microfarad, not 0.8 microfarad. But that was all right. If we go back to the version 6 and zoom in here, you can see they clearly said um, 8 microfarad, right? And they used the all uppercase MFD. This one used lowercase MFDs, but it's 8 microfarads. Okay. Now another thing that throws you off here is just the inconsistencies. The conventions that eventually kind of became conventions were not so conventional back then. Different manufacturers did different things. But if you look back here at the writer, even in the same company, uh, they did things different on their schematics. So this one right here says, okay, if you look at C3, for instance, 100 microfarad, it's a mica cap. So pretty much all mica caps are in the picofarad range. That's just what range they are. They're very small capacitive values. And if you've done any electronics and ran across, repairing stuff, mica capacitors, you know that already. But I just found it funny is they actually use the mu symbols here. So 100 microfarad, it's a mica cap. That's 100 picofarad, right? But if you go to the Writers Volume 7 and the Delta model of this, the Delta version of this model, they say 0.001. Okay. Now, we already know it is 100 microfarad, so 100 picofarad. So what this 0.001 really is saying is 0.001 microfarad, meaning it's 0.001 microfarad or 100 picofarad, right? I mean, it's 0.001 microfarad or 100 microfarad or 100 picofarad, right? So this is really 100 picofarad. So if you went 1, 2, 3, 1, 2, 3, you'd be in the decimal point would be in front of the 1, right? And because that's already micro, then that's 100 picofarad, which is very strange. Okay, I mean, another thing I found that was weird was some of these capacitors have a straight up, plus or minus uh, tolerance on them, and then some of them have like a 50% over, 10% under type of deal, which is kind of odd. I've seen that in some other capacitors before, but that just struck me as odd. So this could be as high as a 0.15 or as low as a 0.09, I guess. Yeah, so yeah. So again, to recap on this, MFD, that's microfarad. It's usually a capital MFD though. Uh, like you saw in this Writers Volume 7, capital MFD. And that's typically what's stamped on the capacitor itself. That's the value that the capacitor itself says on it. And that was not foreign to me at all, because that carried all the way up into the 60s. Uh, but this thing right here where you see, 0.00038, I would have thought that was just the number. But then I think, okay, well that's you know, or 0.000.0001. It says mica. Well, I pretty much already know that the micas are in the picofarad range. So the only thing I can speculate on this, if I didn't have any other reference, was that this is really 0.0001 microfarad, right? Which it is, because when you go back and look at this, it's actually 100 micro or 100 picofarad, right? So that's just something to you know that you have to wrap your head around. Another thing about radios during this time, um, there was kind of two in the 30s and 40s. There was a mixture of varieties. Okay, sometime in that area, I think more in the 40s, they started going towards permanent magnet speakers versus your electrodynamic speakers or your field coil speakers, right? This particular one has a field coil. You can see it is right here. So it's a field coil speaker. And this is another inconsistency that you're going to come across on these schematics. I'll show you what it is. This one shows you how it is in the circuit electrically. Okay. And then which in actuality, this field coil is in the speaker, like mounted on the back of the speaker, right? The field coil is, it's the electromagnet for the field coil, right? And then the actual coil itself, it creates the magnetic field, right? The coil itself, for the speaker itself, is this coil that's shown right here. Okay. Now, in actuality, those two wires right there get its connection from the P and the B plus portions of, let's see, P and B plus portions of this socket right here. And then the F field and the ground, that's these 2 points right here. Now, I'm about to scroll to another schematic. Okay, the very next one actually, made by Belmont. It is the model, what is it? Model, what is it? It's the model 586. So the next model up. And they actually break out the speaker and the field coil out here on how they're connected to the speaker thing, right? How they're actually wired to the speaker thing. And then just put the speaker. So this is the actual speaker jack, and this is the speaker plug. Excuse me, this is the speaker jack right here, and this is the speaker plug up here, and this plugs into this jack right here, and this is where the wires connect to. This is actually accurate physically how it actually is in the real system, whereas this way up here is just a schematic representation electrically of how it is, but not physically how it is. Okay, so you have to kind of wrap your head around how's this thing really, how's this really going. This right here is electrically sound, but not physically sound. Okay, and then in order to reconcile that, they put this little diagram in here, and you have to match up the letters. Okay, on how it goes. Okay, so that's another little flaky thing they did back then. Kind of strange, but yeah. The last thing I wanted to say about this, well, actually, there's two more things. There was also a mixture of non-transformer and transformerless or AC/DC radios at this time. Okay, your AC/DC radios or transformerless radios were series filament radios. They were meant to just run off the line voltage, and in some cases, some people had DC at their house, especially in places where they didn't have the utility at all. They would have like maybe a wind turbine. Yes, they had wind turbines all the way back in the 30s and 40s. I actually know a guy who grew up and he didn't have utility power ran to his house until he was like 10 years old, and that was like in the late 40s. But so they would have like wind turbines and batteries at their house. That was their source of electricity. I mean, they had DC electricity. That was it. And these radios could work off of that, and they could also be battery powered. And they were big batteries, but like some 90-volt batteries and stuff. But and so those were the transformerless type. Not very safe at all. There's many things wrong with them. You can make them safe, but there is no isolation on those. These type with the transformers, they had non-polarized plugs, but that really didn't matter with these because there was no tying to the chassis at all. So from the line, it was completely isolated. So it really didn't matter how you put this in here. Now, if you did put it in here wrong, you could have this coil energized, but no current would be passing through it. Okay, because the switch would be open here, right? So you wouldn't have any current flowing through this, but you would have voltage on this primary winding right here. So what I do when I restore these, if you go to Antique Electronics Supply, they actually sell these brown antique cords. I mean, they look like what would have came on these. Okay, I think people call them rip cords or zip cords. I don't know what they call them exactly, but they're just two conductor cords, power cords, and they're already tinned on the end, stripped and tinned on the end. But the only difference between those that they sell and what would have came on one of these originally is that actual plug itself is polarized. Okay, and so when I install it, I always make sure that the side that is going to be plugged into the hot side, which is going to be the small prong, is the wire that goes to the switch comes from that. Okay, so that way when you switch that off, that's where the that's as far as the voltage goes, is that switch right there. So anywhere else in the radio, anywhere, would be completely de-energized unless that switch fell somehow short. Then that's as far as it goes, and I just do it that way. I don't ground it, I don't do any of that stuff. I put it back the way it was originally. It's perfectly safe like this. Now you can say, yeah, if this thing develops a, a, a short or something in here, uh, possibly there's some, but there's no return path back to your, there's no connection to ground here, so there's no return path back to your your breaker panel at all. And this separates you from the line side on this side, so this is completely safe like that. Anyway, I'm not going to get into that, but maybe we'll do a whole nother series on that as well, because there are some there's some downsides to having different types of configurations like this. But that's just one thing right there. The last thing I wanted to show you is this particular item right here. I go to my radio equipment folder. Again, I had the Byteman and the Riders, and like I said, I'll put links to those in the description. But this right here, if you're going to restore old radios, AM radios, FM radios, whatever you're going to be doing that uses a dial cord, in other words, uses a and not all radios do this. Some are direct drive on the tuning tuning capacitors, but most radios, though, if they have some kind of dial indicator or something that indicates what the the station that you're tuning to is, you're going to have some kind of mechanism in there, and sometimes they're pretty complicated. And you're going to link your tuning knob to the capacitor gang, the tuning capacitor, somehow via whatever mechanism. Okay, and typically that's done through what's called a dial cord. Okay, it's just a nylon string, and sometimes it can be very intricate and go through a bunch of pulleys and tensioners and all kinds of stuff before it gets to where it goes. And you need to have so many turns and all this stuff, right? And it needs to be, you know, clockwise or counterclockwise or crisscross or all kinds of different ways. And if you get this radio and there's no dial cord in it anywhere, like it's gone, it's missing, or it's laying down in the bottom of the chassis, you have no idea how this thing gets restrung. There's this manual, there's actually several of these, but this is just one of them. It's the Sam's Dial Cord Stringing Guide. Okay, this one covers all radios from 38 to 47, and this is around the time frame of type of radios that I'm working on, so that's why it benefits me. And it doesn't have every radio in it either, as I found out, but a lot of radios use the same types of mechanisms, and you can find what this one, whatever particular radio you were working on uses. But if you go through here, you can, look at like a General Electric. Let me zoom in here. General Electric, JB05 or whatever. It's diagram number 211. And then you can go down to 211. I'll just scroll down through some of these so you can see them, but right here, like right here. So here you go. This tells you exactly how that needs to be. Some of them require springs. So like you'd put a spring right here, wrap it around here. It goes around through some pulleys, around the main pulley here, back up, terminates. So this is a very good. It's got all different types of, and why in the world there was this many types out there, I have no idea. Why they could not just say, hey, this is how we're going to do it. Okay, but there was just so many different ways that they did tuning. Some of them, the tuning indicator went across like this, across the face of a dial. Some of them was in a circle, with a needle, looked like a needle, like a meter movement. Um, there was just all kinds of different ways of doing it, right? So, in different sizes, you had floor models, you had desktop models, uh, you had, bookshelf type or whatever, tombstone, cathedral, all these different types. They're just lots of different form factors and everything. So they had to have different ways of stringing these up, but you can see all the different. I mean, there's just hundreds of them, and this is only volume one. I think it goes up to number four. I think it goes up to four or something like that. But everyone that I've needed has been found in this one. Uh, so I didn't download the other ones, but I may have to go in there sometime and get those other ones. But so yeah, I hope this helps. Um, again, oh, if you cancel, if this helped you out at all, please give me a thumbs up. And again, I want your comments down on the bottom. If you got any comments, uh, have a discussion on this. And like I said, I may end up breaking out some other portions of this and making some other videos on there, and even include some of my repairs and restorations in some future videos too coming up. So that's all for now. Appreciate it. And I'll see you on the next video.